So here we go with a hard video then. Gonna try to convince you of this idea of how the moon got its orbital period equal to its rotational period. So I'm gonna go, wish me luck. The process is called tidal locking. So here we go. It's not unusual for the solar system at all. Okay, so it starts like this. Let's suppose then that the moon orbits around the Earth. And so here's the Earth, the blue planet. Here's the moon. And whenever you draw two things that are gravitationally attracted like this, there is a line that connects the two centers. And technically, this is the line that gravity acts on. Sort of the direct line that joins them is the line that gravity acts on. So as we said, because of this delicate balance bit with the orbiting, the moon is a bit warped. So the moon might actually look like this. And my warping is very, very exaggerated. Don't go quoting me on that, but I'm just trying to make my point. There's the warping. Okay. And remember what warping involves. It involves rocks and energy. Okay, the rocks are actually all bunched up together and they're forced to drag besides themselves to take a planet from this configuration to this configuration. You can imagine that, say, if the Earth was made up of all these rocks that are all broken up now, the rocks would have all had to drag against one another like this, like kind of sound like that, in order for the Earth to go from perfectly round to that. Rocks are actually dragging on each other, and it takes energy for that to happen. The rocks are going to heat up because of friction. Like you start imagining this sound like that, rub your hands together like that, they'll get kind of warm. The rocks are doing the same way. So that's a bit of warping going on. Now what happens? Well, the planet is going to stay in orbit, we know that, and so it's going to have some speed this way. So that means a tad bit later in time, this warped planet is going to maybe be over here, with the warping like that. But now wait a minute, the problem now is that, okay, you have your warped planet that's moved up there, but now suddenly because the planet is up there, this gravity line that lines the two isn't quite lined up anymore. I mean, look, the warping, which is along this red axis the way it was down here, is no longer along that gravity axis anymore. That's bad, because the warping always has to be on the gravity axis, because that's just the way the process works. The gravity always pulls along a line like this, not along this line over here. So something has to happen. So the question is, well, what's going to happen? Well, could it be that the planet is just going to naturally want to rotate itself down to line up with that gravity line? Like, will the planet just suddenly rotate down like that? And I think, yes, that is part of the answer, because there's something called a torque that would develop on the planet. But it's something maybe I need to read up a bit more on, because I also know that this gravity effect here doesn't abruptly change the rotation of the planet. Like when the planet's aligned like this, it's not abruptly going to go whoosh to get that warping line back up with the gravity line. That would sort of affect its rotation and all that stuff. But what actually happens is the warping will realign itself. Let's say it's going to start to look like this now. The warping is going to realign itself like that, but it does so with more dragging of rocks. That's the way the warping aligns itself with that gravity line, not with an abrupt rotation of the large warped planet itself. So you have the warping is here. Now the planet orbits up there the way it is, and in order to re-warp, in order to always be lined up with this line of gravity the way it has to, the rocks go through another motion again as they drag against one another to get warped properly. That's kind of a cool word there, huh? Get warped. And the process sort of repeats itself. This green warping is going to be up here as the planet keeps moving, but once again, the warping isn't along the right line anymore. The warping is sort of off a bit. The red line is off, and so the rocks are going to re-warp again, re-drag, in order for the planet to stretch out along that line of gravity again. Now, the point of telling you this here, and I think I'm slowly starting to reach my conclusion, is that every time the rocks go, they get hot, and they start to release energy because of friction. frictional heating of the rocks rubbing against each other. And so you can picture these rocks here. I need sort of a better fiery color here. Let me choose maybe like this one right here, this orange right here. That's the same one maybe. So you can imagine as the rocks are working, yeah, of course I chose the same one. You can imagine this heat coming out of the planet like this because of this warping here. This is heat due to rocks. Rubbing. Okay, it's heat. So this heat actually comes out of the planet because the rocks are rubbing against each other and getting hot. So rocks rubbing into each other, huh? Rocks rubbing into each other. I'll tell you the ramifications in the next video.